we have two seasons, winter and preparing for winter, as far as I'm concerned. And because you spend all summer doing stuff for the following winter. Anyway, got some stuff here in the shop I've been doing, and we'll swing around and we'll go check a couple things out here. This is the new 3D printer enclosure right here. Has a removable lid and a window in the top, which allows the light to shine down inside, and a window in the front. Cardboard box cut up, taped together, and a little bit of hot glue to glue the windows in. But this makes a huge difference. It's actually just amazing. If you don't have an enclosure around your printer, I don't know if you can tell. Can you tell there? This box here is printed with the enclosure, and this one was not. And you can see how you get this lifting. And really what it is, it's layer shrinkage is what it is. And oh, I got a green shirt on. That doesn't help, huh? But here, hold that. You can see that curvature a little bit. Now, so what that is shrinkage. As the layers cool, the first layer goes down, bonds to the surface pretty good, your platen, and then as progressive layers go on, they shrink as they cool, and they can pull, and that's what causes this. And having an enclosure has made a huge difference on the flatness of the products here, of my boxes. So I'm trying to print a bunch up for prospective customers of dovetail cutters. Some will get a curved box. The inserts just fell out of there. Anyway, so the enclosure is well worth your time to put something together to keep the warmth in there from the platen staying warm in a more constant temperature and less cooling too fast. So you do get a lot better print. Learn that off of CNC Kitchen. CNC Kitchen, I think it is. The YouTube channel. Young man, and I think he's in Germany. Does some really great information on 3D printing, and he does a lot of testing of materials and actually very scientific actually for shear strength and all that good stuff. Tensile strength of materials and prints. And he tries out all sorts of stuff and a lot of CNC printers. So a lot of good, very good resource to watch and find out about, why you get the shrinkage and things like that, and how you can cure it. But or any other things about 3D printing. So he's a pretty good channel. So you should check him out. I'll get a link in there. These are some other 3D printer projects I've been working on, and it's an oil cup. You can see the brush, right? And it's a one print oil cup, no spill. You could put a weight on it if you wanted to. Boom, boom. It's hard to tip over anyway, but it's a no spill one with the tube and everything. I've had oil in them for over a week, getting no leakage on the sides or anything. So I'm pretty happy about that. Just PLA, but I put logos on them. Got my logo on one side right here. I kind of was doing this before Mr. Pete's meet and greet, and I had sent him the file. He printed one and without logos, but now I've got logos on them, and then I got his on the other side. Now I ran a Sharpie over the top. It's a raised letter. My plan is to put this on Thingiverse for anybody who wants one. Came out really nice, and they work real well. They don't hold a lot of oil, but they're not intended to. Boom, boom, brush in there, and sloped on the top, so it drains back in and everything. But they actually work well. Somebody mentioned, or a couple people mentioned, they saw one on my lathe in one of the last videos, and but that's what it is. It's an oil cup I printed up. A couple other people have I've sent this to, and they've printed them up also already to test out, and it seems to be working pretty good. There you go. Another 3D printing project for the shop. I have one on every machine now. These are two cups I've had sit here for 7 days now on this towel, and I'm getting no leakage on them. So it came out really good, actually. Except for the little bit I spilled on the face, of course, but that's all right. But other than that, really no leakage. And you know, if they did leak a little bit, it'd be hardly anything. But they sure work good. One other 3D printing project I did, designed up some new scope caps. The ones here were kind of busted and everything, so little stretchy cords and some new scope caps. These come out great. This one fits really nice, and this one's a little bit looser. They're both the same size, and this one's a little looser on the front, but they sure worked out good. Mr. Lee Peden of Tim Barn Time had made spacers for me and sent them to me. They have magnets in them, so they clip onto the press here, all different sizes. I have a little piece of DOM tubing I also use. What I did though, I didn't have a place for them, so I made a quick little mount out of DOM tubing, 1.5 DOM, and now I have a nice little spot to store them. They can just all sit right there together, and came out pretty good. I like that. And probably put the tubing on here and do that. So everything is all stored right here on the press. Simple, nice and easy. A little shop hint here. Actually, I discovered this kind of by accident, but I've been using, this is Permatex brand aviation gasket compound. And it's nasty stuff to get on your hands and on things, and it's almost impossible to get off. This is Loctite brand, Permatex, or it used to be called Permatex, but Loctite, it says get number 1 and number 2. Number 1's a hard setting, fast drying type material, and the number 2 is a non-hardened, pliable, more of a little softer, but it's nasty to get on your hands, on your skin. Very hard to get off. We used to use this stuff on the ship all the time. It was always a pain. But denatured alcohol takes it off like you wouldn't believe. This jar was covered with it. This tube had leaked and was all over it. And a little bit of rubbing and it takes it right off. So denatured alcohol, great solvent. And this one was getting kind of thick in here. And I've had this jar a long time, so I put some inside, and now it's very, very nice to use. I mean, it's thinned out a bit and just right, just almost like new. So anyway, denatured alcohol for cleaning that stuff up or cleaning it off your hands or whatever it's on, or on a surface that you had to clean up for gaskets. This is the compound on my Lance lathe, and I have had a problem with this since I've had the lathe, of course, and I finally had some time to do something about it, and because I really needed to make a cut here that at a slight angle. So whenever I would, this here handle, so it's put on with a taper pin, and whenever you try to do a slight angle, you would hit either this hand wheel or the knob. This here will hit the dials on the lathe, or this handle is just too big. You know, it hit here, so you can't use it straight or at a slight angle, or over here on the other side you can't. You know, you just hit all the time. So I finally took this off. And if you follow me on Instagram, you saw a picture of this. So I made a new dial, and these just screw in, nice little tapered handles. These here the handles I made out of W1 and heat treated them, so they're nice and hard. They're about 50, 55, somewhere in there, and came out pretty nice. I made them so they screw in on purpose, and then I went to put it on, and of course I made it so the holes in the center and all that. So what I did is I took a 1-inch socket head cap screw and I cut it at 1/4 of an inch per foot. That's the taper of a taper pin, and have some threads. So it's a removable taper pin. So we'll go right in here and fit in the shaft. Well, when I went to do that, it didn't line up, because when they drilled the taper pin hole, they didn't put it in the center of the shaft for the old hand wheel. This is not in the center of the shaft, so that didn't work out too good. So I had to drill a new hole and ream a new hole out for the new handle. So I just cross drilled it 90 degrees off of this, and that lined up, of course, perfect. And then having this taper pin screw now, it can just drop in and you can screw it in, and it's easy to take off if you need to get it off. And it just makes it real nice. But anyway, so now I can put this anywhere and still use the compound at any angle, and except all the way in the back, but I can get a lot closer. That's very close. You would have a very tiny dial for that clearance. So this worked out. I was mainly concerned in the front, so now I can have it pretty much anywhere, as long as this turns sideways, but pretty much anywhere, and still use the compound. This was really bothering me. So I made these threaded, because I haven't made it yet. I'm going to make a piece that will go on here, and these will thread through so I can drive it with a drill motor and stuff. So anyway, but this came out pretty good. This was made out of pre-hardened 4130 I had here. So pretty happy about this. This was a big problem. And then a wonderful viewer I have. What a wonderful viewer. Mr. Tom Eason out in Tennessee sent me a Derek's drill sharpener. And for whatever reason, Tom was having troubles getting drill sharp with it. So thank you, Tom. I've been really playing with this thing a lot, and I found a few things wrong with it. And the mount here for the chucks that go in here was loose on this shaft, and so you don't maintain an angle, your proper angle, when you adjust it down here for your drill angle. This here should turn. I have it set at 118 right now, but this would turn on you, so that'd screw you all up. And the pins on this piece here goes up and down. There's two little roll pins. Well, they weren't right, so that it would come out of the groove and it wasn't traveling straight up and down, and it would get cocked. So I fixed the pin issue. I cannot get this out of here yet. I'm afraid to beat on it too much. This is only aluminum, this top part, but this is made of steel here, this pin, and I need to get that fixed to this better. It's still loose. I have it kind of stuck right now, but it is loose, and so I need to fix that still. But I've been having some success at sharpening. If I hold things pretty good, but I'm still figuring this machine out. I have the instructions printed out. This is I don't know what model. It doesn't say exactly what model, but it's the same as a M4 or M5 plans. I printed out. I was able to get the instruction manual online, and I think their instructions are kind of hinky a little bit, They don't tell you about this adjustment up and down here at all. They show it. I mean, there's the picture that it has in the instruction manual, but they don't tell you why you adjust this. If anybody out there has one of these, maybe you can help me out with it. I have sharpened some drills and I test them and they work great. But then some I have a hell of a time getting the proper angle on. Now, you know, this turning was a problem, but you still, it's just, I don't know. Using this, I don't know if this has gotten screwed up a little bit, which I kind of think it has, because this band has degrees on it, and if you adjust it here to get it so it snugs down tight, it changes where that mark is. And I think part of the problem is this. Up here, it moves a little bit just when you snug it. So if you change it here, you're going to adjust it a little bit. And then they say it's just for your clearance angle, but I kind of have my doubts there about how it adjusts this and aligns it up. And this isn't the best aligning tool to align the point in your chuck. I don't know. I've been playing with it and trying all sorts of different things. I mean, I've spent all day, several days, playing with this thing. Like I said, I've gotten some drills sharp and they come out great, but then all of a sudden you don't. So I know it has to do with diameter of the drill, and I understand all that and all the geometry and all that stuff. But you know, like I said, that every once in a while, I mean, still you have an issue. The drill doesn't turn in here. The chucks work good. Everything works good. Just the major thing was this thing being loose. So anyway, this is for thinning the web and your secondary relief angle here. So, and it all works. It runs great. But I'll be working with it some more and stuff on it. But if anybody else owns one of these and ever had troubles with them, please chime in and let me know, and I'll correspond with you if we can figure something out a little bit. But thank you again, Tom. This is going to be a great tool here for the shop. Just a wonderful thing.